We hope you have gained a nice glimpse of how battery laboratories look like and that it triggers you to step further in this MOOC. In this section, we will dig into a simple battery system that you can easily make at home. But remember that a rechargeable battery with its electricity storage must receive its electricity from somewhere. We are going to show a battery system that works only via concentration difference, where fresh water from a river meets the sea. This is a so-called osmotic battery. But before we are going to show that, we will say a little more about several forms of energy and how to convert one from to the other. Since battery works basically by storing electricity in a kind of chemical energy, this means electricity has been converted into another form of energy. This electricity, of course, is also coming from somewhere. Pumped hydropower, which is potential energy, wind turbines, kinetic energy, solar cells, heat with geysers, or nuclear power plants, etc. Energy is usually measured in joules, or in the past in calories. This means we can calculate every form of energy in joules. Electrical energy, for instance, is known to occur at a specific voltage, in volt, with a current, in amps, during a certain time, in hours or seconds. Hence, volt times amps times seconds gives joules. Similar relations can be derived for potential energy, kinetic energy, etc. They all give energy in the form of joules. In order to convert energy to another form, various systems have been developed in the past, such as alternators, engines, heaters, solar cells, windmills, to name a few. These might be already quite obvious. The one that is maybe less obvious is the one on concentration differences, as we will see here. Concentration differences of salts in water can be used to create electricity, as we will show, and you will prepare as a battery in the end. Actually, this creating of energy is known as osmosis, a process that is going on in your own body every second, keeping you alive. But how does it work? Imagine you have a beaker with a high salt concentration and you pour very neatly water with a low salt concentration. Then after a while, the concentration will be leveled. This is what you see here with a yellow iron sulfate solution and not a solution of rock salt, because that is colorless, but would behave basically the same. It means there has been transport of salt, and that is kinetic energy. This kinetic energy we would like to use for converting it into electricity, and that is what we will show you here. Blue energy is perhaps one of the most underexploited resources of green energy. Blue energy can be seen as osmotic behavior when fresh water of a river meets salt water of the sea in the estuary. A chemical process, similar as occurs in our living body, allows for electricity generation once an adequate system is being developed to harness it. How does it work? As said earlier, concentration difference of salt in water can be used to create electricity, which is referred to as blue energy. It works as follows. We place two vessels against each other, separated by a membrane that does not allow salt to pass. The only species that are allowed to go through the membrane are water molecules. That means, to arrive at a concentration that is the same at both sides, water molecules go from the left vessel to the right vessel, leading to a difference in height. This height is potential energy, and can be regarded as pumped hydropower that can be converted into electricity by releasing that water and driving an alternator. This whole idea can use to place huge installation at a place where fresh water meets salt water. Not surprisingly, where a river flows into the sea. Mentioning this huge installation using blue energy, actually, one has been installed already at one of the famous dams in the Netherlands, the Afsluitdijk. This dam was built in the 60s to control what was formerly called the Zuiderzee, but it is a lake now, het IJsselmeer. In this lake, fresh water from the rivers is collected, and at the other side of the dam is the sea, the Waddenzee. And here electricity is being generated via that simple osmotic behavior. Hence, you can see this as a massive battery, which can operate without any intermissions from the supply of fresh water. Intermissions are however taking place only during maintenance, of course. Despite the size of the system, the actual energy density remains low, but the size itself will certainly compensate for the overall storage capacity. To give you an idea on the voltage of that the system provides, we will show you the following data. Typically, the concentration of salts in seawater is about 30 to 40 grams. In this example, we took the salt concentrations of the North Sea, which are 24 grams sodium chloride, 5 grams magnesium chloride, 4 grams sodium sulfate, and 0.8 gram magnesium bromide, 0.7 gram calcium chloride, etc. If we only take sodium chloride as the active salt and measure the voltage versus the concentration difference to the water that comes from the river, we see that we may expect this to about 0.3 volt, which is certainly low. How this voltage depends on the concentration difference can be calculated by this logarithmic equation. This results in the following figure. Analyzing the voltage becomes a little unclear at low salt concentrations, and therefore the voltage can be better plotted via a logarithmic scale of the concentration as shown here on the right hand side. Using this information, it means that if we have vessels where in the end the concentration becomes equal, there is no voltage. Luckily enough, the river supplies a constant flow of fresh water, and the concentration of the salt in the sea will not change that much, and so we may expect a constant voltage over time. Hopefully, we gave you a good understanding of how an osmotic battery works, and this will be the idea for you to make an osmotic battery yourself as homework.